What's the big deal with line sets? On an air conditioner, you have a fat line called the suction line. It has insulation on it. The small line is the liquid line, and it doesn't. The diameter of them is just whatever the connection size is on the outdoor unit and the indoor coil, right? Wrong. In this video, you will learn that improperly sized line sets can lead to operational problems, noise complaints, loss of efficiency, and even compressor failure. The three physical factors that must be considered when sizing a line set is the amount of refrigerant in the system, the pressure drop, and the velocity of the refrigerant flowing through the line set. Each equipment manufacturer will have their own rules that must be followed in terms of piping design. Where do you find these rules? In the installation instructions. Do not just install line sets that match the fitting size on the outdoor unit or the matching indoor coil. Here is one manufacturer's liquid line sizing chart. Looking at the 1.5 ton system capacity, you can see that a 5/16 connection is on the unit, yet a 1/4 inch liquid line should be run on lengths up to 70 feet. Let's look at the factors that must be considered when sizing the suction line. It must be large enough to minimize the pressure drop, which will minimize capacity loss. But it also must be small enough to keep the velocity of the refrigerant high enough to pick up and carry the oil back to the compressor so that it can continue to lubricate and do its job. Inside the suction line is a mixture of refrigerant vapor and refrigerant oil droplets. They should be mixed together. It's the velocity of the refrigerant flow that keeps them mixed and keeps the refrigerant oil moving along back to the compressor. Engineers have learned that by keeping the velocity in the suction line at approximately 1,200 feet per minute, they will get good oil return to the compressor. But you don't need to remember trivia like this. Just size the suction line properly and you will have the correct velocity. The concept of refrigerant velocity in the suction line has always been vital on heat pumps, but today it has become increasingly important as our industry starts incorporating two-stage and variable speed compressors into air conditioners. In addition to ensuring proper refrigerant velocity, the right size suction line will be large enough to minimize pressure drop. Pressure drop reduces cooling capacity. If the suction line is too small, there will be lots of velocity for good oil return, but the increased resistance to flow will reduce the capacity and reduce efficiency. Why is this? Because the lower suction pressure will result in refrigerant gases that are less dense. The compressor will pump less volume per cycle, resulting in lower capacity and poor efficiency. In the past, it was common to install traps in the suction line when the condensing unit was located higher up than the indoor evaporator coil. This is no longer needed. In fact, it's undesirable. They just add pressure drop to the system. Proper line sizing will result in proper velocity and good oil return to the compressor. Now let's look at sizing the liquid line. A properly sized liquid line must be large enough to minimize pressure drop, but small enough to also minimize excess refrigerant in the system, which can damage the compressor. If the diameter of the liquid line is not large enough to minimize pressure drop, we risk creating a condition where the liquid refrigerant will flash to a vapor before it reaches the metering device. This can create a loss of capacity, could damage the expansion valve, or result in a noisy evaporator. Because the evaporator is now starved for refrigerant, high superheat levels will result. Without the cooling effect of refrigerant vapor in the proper temperature range, a compressor burnout is right around the corner. One of the goals of a properly sized liquid line is to minimize the amount of refrigerant in the system. Excess refrigerant can damage the compressor. During an air conditioner's off cycle, liquid refrigerant will always migrate to the cold spot in the system. This can often be the compressor crankcase. When the system restarts, all of this excess refrigerant will pick up the lubrication oil from the crankcase and wash it out and carry it out into the system where it can no longer lubricate the compressor bearings. For example, did you know that a 3/8 inch diameter liquid line holds well over twice as much refrigerant as a 1/4 inch liquid line? What happens if a manufacturer recommends a 1/4 inch liquid line, but you install a 3/8 inch liquid line? Obviously, you would need to add refrigerant. Consulting the manufacturer's chart, we see that you would need to add 0.6 of an ounce per foot for every foot over 15 feet. For example, 50 feet minus the factory charge for 15 feet equals 35 feet. 35 feet times 0.6 of an ounce equals 21 ounces of refrigerant that you would have to add. How much cost will this add to the job? Well, if we figured $10 per pound for R410A refrigerant, 21 ounces of it would be $13.13 plus your labor. Is there any benefit to this investment in extra refrigerant? No. The system performance is worse. So repeat after me. The equipment manufacturer is always right when it comes to line sizing. When it comes to refrigerant line sizing, bigger is not necessarily better. Refrigerant line sizing is very important. Incorrect line sizing can lead to a host of problems, including potential compressor failure.